Hi, this is Margo. This is Thursday, August the 2nd, 2018. And I'm starting out with my new favorite slogan, Power to the Truth, because we're here searching for the truth in these end times. And this is my ClimateCast update. My last one was last Saturday, the 28th, and you're going to see drastic changes in the Arctic sea ice, and we have whole sections that have really just collapsed and fallen away. And I'm on Climate Reanalyzer here, and this is the sea ice and snow cover from today, and you can see this whole area has gone, and this is basically overnight. It's been going, but it's basically overnight. And I'm going to start out with my slideshow. I'll open it up, and I have a new program that I'm using. It's called Honeyview. Thanks to one of my viewers sent me an email and recommended that I get this view program, and it does something really cool that I'm going to show you in a minute. But it's to view pictures, and I'm going to show you something else that it does. You can make slideshows and all kinds of things. So this picture is from Climate Reanalyzer from last Saturday the 28th, when we did our last update, and you could see that the sea ice was losing its integrity, and it was very thin, and it's getting thin up here too. So we're just going to click through. Here's the 29th, and you can see it melting a little bit more every single day. Here's the 30th, 31st, and you can see a huge thinning from the 30th to the 31st. I'm going to try my arrow buttons. Okay, that works. And here's to yesterday, the 1st, and you could see it's almost all melted through here. And here's today, the 2nd, and there's a huge patch that's gone, that's just gone. It's just totally gone. So there's that. So we're starting out with sea ice on everything. I'm also going to show you, this is the animated GIF from the Navy website from today, and it's their 30-day. And with this program, you can down here click and stop it on a certain view if you want to get a certain frame. And one thing I don't understand about this program is the date down here is different than the date up here. So if anyone has an idea for why that is, I would appreciate it. So let's get that going again. Well, it's only off one day here, but I've seen it off several days. I'm thinking it's because it goes into the forecast period, and their latest data might be from the day before, like from the 1st, and here it is the 2nd. I don't really know, but they go into a forecast period for about a week after the real data. So we can see that the sea ice is thinning and really seriously going away here. And the white is 0, and then the lavender and the light purple is 0.5 meter, and then when it starts getting into the dark purple and blue, that's 1 meter, and then the dark green and medium dark green is 1.5 meter, and then the aqua is about a little bit over 2 meters. So we're losing that thick sea ice. It's really thinning very, very quickly now. It's thinned so much in the last week. So this is forecast to the 9th, which is a few days out. It's a week out. So they're forecasting it to look like this on the 9th of August. And here's that hole that we just saw from Climate Reanalyzer. This is in the Beaufort Sea. And another thing that you're going to see on Climate Reanalyzer, when we look at this 2 meter temperature anomaly, it's been, well, it looks better today than it has looked, but it was really high in the temperatures being too high up here. But we can see that temperatures are higher than normal for this whole western side of North America and going up into Canada, Greenland up in the northern part, and then Siberia up here, all across northern Siberia, and up over the Chukchi Sea and that Siberian ice shelf, and also over this hole where the Atlantic Ocean comes into the Arctic, and on Svalbard there and Iceland. So let's switch in over on the east side of the United States. And we've had like this worldwide heat wave going on, and then we can see it's just like a whole swath of higher than average temperatures in this 2 meter temperature anomaly, starting in your Norwegian countries, heading down through Europe. Spain is really hot, especially on the coast, and then northern Africa, and all the way across these northern Africa countries, and then southern Africa and East Africa as well, and along with Saudi Arabia and parts of the Asian countries. And also you're going to see well, here we have South America next, is higher than normal. And when we looked at this last time, it was much higher during almost all over the east side of Antarctic, and so it's kind of calmed down on at least part of it, but we still see that areas are in the red zone, which is 20 degrees Celsius higher than they normally should be in the Antarctic. And when we get to CAMS, I have something interesting to show you going on in the Antarctic that is a little bit disturbing. I don't know what to think about it, so I haven't seen this before in the Antarctic, so we're going to have to look at that. And then we can see like this whole east side of Australia is really being hit with abnormally warm temperatures, and they're in the middle of winter there. And also New Zealand has warmer temperatures than normal. So we can check out our precipitation. And the green is rain, the blue is snow, and we can see the patterns of the winds here. And we can see that it's raining up in the Arctic Ocean, or the Arctic Sea, near the East Siberia ice shelf. And here is where the ice has collapsed and has gone away. I don't see it raining there right now, but We have that going on. Our jet stream is running right over that area. And also when we get to cams, another disturbing thing you're going to see is the ozone layer is thinning in places that I would not expect it to be thinning at this time of year. Particularly, it's thinning more in the Arctic, and it's really thinning a lot in the Antarctic and in different areas of like the northern hemisphere as well. And I'm thinking it's because there's so much sulfur dioxide that has been collecting in the atmosphere from all the volcanic activity going on. So the next website we're going to look at is the Arctic Sea Ice News and Analysis for their daily image. This is from the day before. This is from yesterday. This is the Arctic. This is extent, sea ice extent, and we can see a hole over here. Now remember, extent and concentration and thickness are different things. Extent is how far out there is pretty much any measurable ice. Now here's sea ice concentration, and if we hit download we can blow this up for you to get a better view of the concentration in the Arctic. And it's gone pretty much around Greenland, and Hudson Bay is pretty much ice free now, and this inlet on the west side of Greenland is pretty much ice free, and it's retreating more and more on the east side of the North Pole, and you can see it retreating more and more around the coastlines. And then here's that hole in the Beaufort Sea that we saw over here on Climate Reanalyzer as well. So let's go back there. But this looks bigger, and I'm thinking it's because this is August 2nd and this picture is from August 1st. So it does make a difference. One day makes a huge difference when things are melting as fast as they are. And I was messaging with Robin Westinra today, and he said, "Are you going to do another climate update soon?" And I said, "Yeah, I hope to. I'm still recuperating from moving equipment around and getting my new computer set up and learning a new operating system and installing programs and learning programs, and you know, it's a whole new learning curve." And we were chatting about how fast the sea ice is melting, and I said I was shocked, and he said he was too, but it was to be expected. And so we can see that it's the concentration is getting much less around the edges again and up here, and I expect to see pretty much all of this area gone. All of this area where I'm moving my mouse around, the hourglass around, or the magnifier. I expect to see most of that area gone within the next week. And I may have to do some updates in between what I would normally do, where I'm just doing sea ice updates rather than doing a whole climate cast update like every couple of days, because things are really going downhill so fast, and it's such crazy weather with the wildfires, and it's in the flooding and in the hurricanes and the cyclones and the volcanoes, and it's just hard to keep up with all of it. Okay, here's our sea ice extent graph, and we can see that they are a few days behind. They're not even into August yet with the graph. So here we are. That's like, I don't know, July 20th or something, and it was heading down. Here's the Antarctic, and it's still growing because they're still in winter, so it's still moving out. And one thing you will see, I forgot to show you on Climate Reanalyzer, the Antarctic, you can see that the sea ice extent is really going out because it's winter time down there, and so it is inching out. But it's not very thick. I didn't mean to do that. It's not very thick. And they do have holes. These little dimples are holes. So that's kind of, I don't understand that either. So here's the concentration. And we can see it's not very concentrated on the east side. And we can also, when we blow it up, we can see that right along the coastlines it's not very concentrated. And I don't know why that is. It just is. And there are holes where there is no ice. So I'm thinking that the ice down there might be more choppy than the ice in the Arctic. It could even form differently since it's salt water rather than mainly fresh water that it's freezing. So I'm thinking that the formation of the ice could have a whole different quality as well. So there's that. So we'll go through and see all the graphs and everything, and we can see that the Antarctic sea ice extent is about where it was this in July of last year, mid-July. So there's that. And by the way, I love my new computer. It's got, you wouldn't believe what all I've got on it. I had it custom built. I took my old one in, and the guy goes, "What's it doing?" And I said, "It keeps crashing over and over and over." He said, "What are you trying to do?" I said, "Well, I'm doing weather videos on YouTube, and I'm doing live streaming." And he said, "This computer was not built for that." And he said, "We could give you more RAM, but you're still going to have problems." So he custom built me this computer, and I've got this high-speed video card for gaming and all this stuff. And I mean, it's all the bells and whistles, and he did it in a day. I couldn't believe it. So I'm just so grateful that I was able to get it, and now it hasn't crashed once. And so this is my first climate update video where we can get everything checked out, and we'll do our live stream. I'll probably do a practice live stream in the next few days just to make sure that, you know, how everything's working over from TalkShoe over, and just practicing all my settings and everything. And then next Thursday, I think that's, let me look at the calendar, August the 9th, we will have our next Campfire Chats with Margo at 8 p.m. Eastern Time. And I'll make an announcement and put it up around Monday. So here's the Navy website, and here's the view from today, August the 8th, of the sea ice thickness in the Arctic. And so it's, most of it is about half a meter. See, and then when it gets into the blue, it's getting into like a meter. And then just a little tiny bit to the north of Greenland is like 1.5 to 2 meters. And then little tiny places around are about 2 meters in that aqua color. So I'm thinking we're going to go ice free. That's just my gut feeling, and I'm thinking it could be in August, as fast as it's going. I'm really thinking it could be. I want to show you something else. Oh, let's look at the concentration on here. And you can see that the concentration is going down exponentially, and this is where the holes were that we saw. So there you go. There's that. I'm going to show you something else interesting. Oh, I didn't mean to do that. I think I know how to do this. There we go. Here's our portal where we can come in. We can look at the Beaufort Sea as well, specifically, and see the ice thickness. And the Beaufort Sea is like, this is Alaska, and the Beaufort Sea is this area right in here. I don't know specifics about it, but it has its own climate and variabilities and stuff because of the way the ocean, the Pacific Ocean, comes in and mixes with the Arctic Ocean. And so this is where that hole came in, and you can see like there's basically just chunks. And when we look at the NASA World View, you're just going to see chunks of ice there with a lot of open space. So there's that, and this is in the last 30, and this is the 30-day animation, and this is how fast it's been going from about July the 12th, and then it goes into a 7-day forecast period. There's another interesting thing. You can check the ice thickness, the ice strength, and I don't know what this measurement means. You know, I'm not a climate scientist. I'm a citizen reporter here, just interested in this stuff. And so people who do know these things, you can figure it out. But this is compressive strength, so it doesn't look very strong to me because this is down to 0 in the white, and then the lavender is 1 compressive strength. I'm thinking that's how strong the ice is if it's like weight put on it. Will it hold weight? That's just my gut feeling. And we can also look at the Antarctic here. This is always interesting, especially since we saw the concentration on the other one. We can see that the concentration is not real thick. It's like it's white around the edges, which is nothing, and then it's just barely starts going in, and then the lavender is like 1/2 meter. So you have a lot that's just like 1/2 meter going up to 1 meter, and so there's still growing ice in the middle of winter. But according to Wikipedia, the sea ice in the Antarctic becomes several meters thick during their winter time. So I don't know what they mean by several meters. This doesn't look like several meters to me. It looks like 1/2 meter to 1 meter primarily, and then these blue areas are about 2 meters, and then a little bit like the yellow green, like that's 3.5 meters, and that's over at the Larsen ice shelf. So I would expect it thicker over there. So here's their concentration as well. So that's all interesting. Now we're going to go to the NASA World View of the Arctic. They have most of their data in from today. Let's do a reload and see if anything else came in yet. No, these blacked out areas are missing data, but we can see most of it that's important. And so this is the North Pole. This is Greenland here. I'll zoom out. You can get your bearings. Here's Greenland. Here's the North Pole. We can see it's melted further in from the 80-degree latitude over on the east side here. And we can see here's the Arctic Sea here. Here's Novaya Zemlya. This is cloud cover. Here's the edge of the sea ice over on the east side. And here's Greenland. And then we can look up here and see the edge of the sea ice come up, come around, and it's coming around here. And if we zoom in, we can see the integrity of the ice, and it's just like ice cubes floating, basically. It's pretty broken up. So here's your East Siberia ice shelf along here. So let's go back to Climate Reanalyzer. And now you can see here, just comparing. Actually, I could bring up hang on a second, I'm still learning all these programs. I could put this side by side because I have such a bigger screen now. Let's just put this side by side with the world view. And we can use this as Climate Reanalyzer as a cheat sheet here. So we're looking at ice, no ice up here except a little bit on the coastline right along here, and then no ice over here, and then spotty ice along here on the west side. And as you know, if we zoom in, we can get a good look at what this ice looks like. And it's the sea surface is moving and sloshing it around, and wherever it's raining down the ash and smoke and everything from the wildfires onto the ice. And if it's snowing, it's got ash, and so that's gonna make the ice melt faster too. So we can definitely see that this Arctic sea ice, it's definitely taken a nosedive. So I think that's all I wanted to show you on sea ice. See, we've already been going 30 minutes. I could do a whole show just on sea ice, which is what I'll do in another couple of days. Just do a sea ice update. Now we're going to go to cams. And I'm going to start. I want to start with ozone. And Robin Westenra did a really, really good report on ozone. And he really dug deep, and he used some of my links and some of the research I had done. But he came up with a whole bunch of other good stuff too. So I'll have to find his blog post about ozone and put it below. We're going to go to the Antarctic, and we're going to go to total column, and we're going to look at the ozone hole, and our information is in back to Sunday through today. So this is actual data when we run the movie. And these are Dobson units. When it's total column, it's measured in Dobson units down here. So we're going to see a little bit in this blue, not the aqua, which is 200 Dobson units, which is very thin. It's only 2 millimeters. And then the aqua is 225 Dobson units, which is this big area here in eastern Antarctica. And then this greener color is 250 DU. And then when you get into the yellow green or chartreuse, it's 275. And then the darker yellow is 300. The solid yellow is 325, and so forth. So let's load this movie. And what Robin found was evidence that the ozone hole is not coming back, and the ozone layer around the Earth is becoming depleted. It's being depleted, and I'm seeing evidence of it too, and it's quite disturbing. Now we can see it's coming up here as well. It's not just right here around the South Pole, but it's really like moving out. Now ozone is very light, and so it does move around a lot with the way the jet stream moves, but also when you have a thinning of the ozone, the wind goes faster, and with the thin ozone layer, it lets in more ultraviolet rays and more cosmic radiations, and that's more damaging to everything on the planet, because the ozone layer acts as a shield for us. Now you can see that like blue-purple came in here at 200 briefly on Wednesday. So there's that. And now here's something that I'd not seen before. I'm going to stay on ozone, and I'm going to go to surface. And this is how we measure bad ozone. And the bad ozone, and I talked about ozone in my ozone videos. I have a 3-part series of looking at ozone. And if you haven't seen that, I encourage you to look at that, where I talk about what ozone is, and good ozone and bad ozone and all this stuff. So bad ozone is created primarily as a result of sunlight interacting with pollutants in the atmosphere. And right now, the Antarctic is dark. There's no sunlight down there. It's totally dark for days and days and days and weeks on end. And so what we see here is this green area. And I have to warn you, when you come to this CAM's view, when you go from total column to surface level ozone is measured in parts per billion, but the chart down here says Dobson units, and so this chart is not correct for surface level ozone measurements. Okay, so what you can do, you can come over here, and I have ozone pulled up on the plots view, and I have surface level, and you can look at the colors here, and the color that we're seeing is this green here, which is this olive green, which is 50 parts per billion. So let's go back over here. I'm pretty sure that's the same color. Yeah, it's this 50 parts per billion, which is, I don't understand where it's coming from, frankly, because I don't understand what would be down there that would be releasing ozone or causing ozone to be created or released in the atmosphere. And it doesn't look like it's blowing in from anywhere. It starts on this coast where it was so high in temperature anomaly. Remember that? We saw that on Climate Reanalyzer where the temperature anomaly was so high. So I really don't understand, unless there's some kind of geologic activity happening under the snow and ice on land there, and it's being released, because surface ozone can be released as a result of geologic activity, and it can be a precursor to earthquakes and volcanic activity. And I know that there are many volcanoes that they've discovered under the Antarctic. Under this whole area, they've discovered like 138 volcanoes. Some of them are active. There's one active under the Pine Island Glacier over here on the west side. There's an active volcano, Mount Erebus, down here on Ross Island. And when we run sulfur dioxide, you'll see that going off. So I really don't understand this surface level ozone being created in the Antarctic in the dark. So if anyone has an explanation for that, I'd love to hear it. Now, while we're here, let's just go through all the Antarctic stuff while we're here. And now we're going to look at sulfur dioxide, and it defaults to total column, which is what I want, and it's measured in parts per million basically. We have actual data back to the 29th through today, so it's up to date. Now here's Antarctica, here's South America, and what you're going to see when I load this movie is you're going to see so much sulfur dioxide moving over the Antarctic that I think that's what's chewing up this ozone layer and making it thin out. And when we run sulfur dioxide on the world view, you will see, you will be shocked. You will be stunned and shocked to see the sulfur dioxide from all the volcanoes, and it just looks like the earth is bleeding. And it's also coming from the wildfires, and it's just shocking and stunning. Okay, we can see it swirling around, and where it starts over here, like this is from the volcanic activity over in the Pacific Ocean, and then it starts dissipating and swirling around, and the jet stream catches it up and moves it around, and then it gets up in the atmosphere, and it ends up all right over the Antarctic. And right here where that little cream colored spot is, that's Mount Erebus, that's constantly releasing. I talked about that in my Antarctic video that I did. So there's that. Now let's hop over to, well, I've got sulfur dioxide on the brain. Let's just hop over and look at the plots view. Now this new computer is great for this because I've got this widescreen, and what's really cool is we can get the whole Earth, and I don't have to keep moving it back and forth and back and forth, and you'll be able to see your neck of the woods wherever you are. And we're going to load this movie, and this goes back to July 29th, which was Sunday. And so this is sulfur dioxide total column. This is parts per million. This I think it's parts per million. Yeah, it's parts per million. Sorry. So what we've got going on here is Vanuatu, this little island over here in the South Pacific, has been very active with lots and lots of volcanic eruptions. Hawaii keeps having volcanic activity. Here in southern Mexico, we have volcanic activity. We have the Galapagos has still been releasing stuff. We have volcanic activity up here in Alaska. There's an active volcano down here in southern Africa. And then you have the wildfires going off that also give off sulfur dioxide. It may not be red, but it's up into the gold, that golden color, and that's 5 parts per million. And then the dark gold is 10 parts per million. And you'll see, and then the cream colored is 2 parts per million. You can see that just spread over the whole North American continent. And that's from those wildfires. And also the volcanic activity that's just spreading around. And you can see it coming right across the Atlantic Ocean in the southern hemisphere, quite high levels. And then Saudi Arabia has a lot. And then it just spreads around. And then you can see that China has quite high sulfur dioxide. Here's where the Russian wildfires have been going off. I don't know if those are still going off or not. I tried to do a search and there's no info that I could find. And then northern Australia, you have constant sulfur dioxide emission here. New Zealand, you've got it as well. Of course, New Zealand, you've had some earthquakes too. You're a geologically active area as well. So there's that. And next, I'm going to show you ozone. Let's look at total column ozone for the world. And this is the good ozone that we're wanting to measure. And here's our chart down here, Dobson units, just like what we saw on the charts view. And we can see the thinning around the center of the Earth, around the equator, with the aqua and the green, aqua green. That's thin all the way around. And then, so let's run this movie. And what's disturbing to me is how it's thinning so much in the northern hemisphere and also in the Arctic. Notice up here in Alaska, it's really thinning over Alaska and over Russia over here on the other side of the Pacific Ocean. It's also thinning over Norway specifically, and it's thinning over the Himalayas and over China. And then even this chartreuse color is 275, and that's not very thick. That's not very thick at all. NASA says that 3 millimeters, they consider that average, which is 300 Dobson units, which is this yellow color, which is like that yellow color there. But you have to have higher units for it to average out. And I see some higher units, a few down here into the orange and the red, but not enough to average all of these out to 300. I really don't understand. And the good ozone is created when sunlight interacts in the atmosphere and it makes ozone high up in the atmosphere. But in my research, I did find that nuclear power plants cause disruption in the planet being able to replenish and make its own ozone. It causes a disruption. I put that in my ozone video as well. I think it was part 3. And also, above ground nuclear testing blew holes in the ozone layer. So you can definitely see that the ozone layer is spotty. It looks ragged to me. It just is looking ragged. And of course sulfur dioxide will chew it up too. So now let's look at surface ozone. Now this is the bad ozone like we were talking about. And you're going to see when we run this movie quite high levels from the wildfires over in California. See it red? Look at that. It is just spreading out there. You see it up here in Russia where the wildfires are going. And then it gets up into the green area in a lot of places. And this is parts per billion. And when it gets up into the cream color and higher, if you're breathing that for more than 7 hours, that's dangerous to your health, according to the United States Environmental Protection Agency. And it's up in the red zone in the Persian Gulf there. So let's zoom in. We may have to load this movie again. I want to get a little closer in this wildfire area for people to see. It's also high coming off the coast of the Gulf Coast and coming off the east coast of the United States. So let's load this movie. And just as a landmark, that little notch there is Yellowstone. That's a landmark for you. I wanted to start it over. It's not loading. Okay, here we go. We're starting back on the 29th, which was Sunday. And you'll notice it goes away in the daytime. I mean at nighttime, and then it comes back in the daytime. Look at that. That's like almost all of California. And then this is coming over into Nevada. Very high levels. I know that, well, I live in Reno, and Monday I was out all day running errands. It was already planned, and we had the worst ozone readings ever in recorded history on Monday. I thought I was going to die. I'm very sensitive. I was wearing a mask when I went out. And Tuesday, levels were high again. Wednesday, levels were high. Today, we had enough wind to kind of blow it out. So today was a lot better. But Monday was the highest since they've been recording ozone in 1963. And the weather girl said the reading was 172 or something like that. I don't know if that was the air quality index or what. She said unofficially the reading is 172. So anyway, so there you have it. So these are dangerous levels. And so anybody with upper respiratory problems or lung problems or asthma or problems with your eyes or heart problems or anything like that, you shouldn't be outside with these high ozone levels. And if you do go out, wear some kind of mask, because there are also particulates in the air that can get embedded in your lungs and in your membranes, and you wouldn't even know about. Now, we've got some high ozone readings off the east coast of the United States too, right there. Did you see that? And I'm thinking that might be associated with some offshore drilling going on. So, that's what's going on with ozone. And it's popping up near Yellowstone as well. I don't know if there were wildfires over there. Possibly. I just, it's hard to keep up with everything. I do my best keeping up with what I can. Of course, there's some popping up in Canada. There's just stuff the world is bleeding. To me, it just looks like the world is bleeding. Let's look at, I'm going to close some of these windows down. Let's look at, I want to end with methane, but I do want to show carbon dioxide. I have an article I want to share on methane too. It just came out today. I think you'll find it quite interesting. Okay, here's carbon dioxide levels worldwide. Total column. This is in parts per million. And this chartreuse color is 407. So down here, like that's 407, then 408 is the yellow, gold 409, the dark gold or orange is 410. So once you get into the orange regions, that's 410. 410. Red is 411. 412, 415, and I'm thinking the black is 600. I don't really know. But carbon dioxide is also a byproduct from wildfires, and so you can see this whole area over the western United States is just black in carbon dioxide, and that's from the wildfires. I feel certain of that. And you can see it over parts of the Amazon in South America. You can see it black in the Congo, in Africa, and over parts of India. So this is not looking good. So let's run this movie. Usually they only have a couple of days of data on carbon dioxide, and then it runs into the forecast period. So methane and carbon dioxide, for whatever reason, their data is lagging. And then we can see some pockets where it does go down. I'm thinking that's the wind just blowing it out, or keeping it in one place, keeping it kind of away from the Arctic as much as possible. But it is getting up there in the Arctic. It's up in those higher the green areas, the green zones. So there's carbon dioxide. So I'm going to close that out. And now we're going to look at methane. I already have it pulled up. We're surface level. This is parts per billion. And we have 2 days worth of data on methane. I think it's Sunday and Monday. Yep, Sunday and Monday. Now this is the Antarctic, and that purple is this level down here, which is like less than 1660 parts per billion. So we're going to switch views to the Arctic. I want to start there, and I want to be, now this is total column, so methane is quite high all the way through the atmosphere, especially over here in Asia It's quite high. It's like 2,000 parts per billion over Asia, total column. So we're going to go to surface level. And here we are looking down on the North Pole. Here's Greenland. Here's our Norwegian countries. Here's Novaya Zemlya. Here's Siberia in Russia. We've got a huge black blob here. We've got a huge black blob over Asia and China. We've got a huge black blob over Norway and Sweden. And when we get over to the United States, you'll see huge black blobs too. So, let's go back to the beginning so that we can see what's going on in the Arctic here. And there are wildfires and all kinds of stuff going on. While that's loading, I've got an article I want to share with you. This just came out today, 15 hours ago. This is from EOS, Biogeosciences Research Spotlight, Journal of Geophysical Research. Rising seas increase methane emissions from the mouths of rivers. So here's another source of increasing methane. Drowned river deltas exhale large quantities of greenhouse gas, new study finds. This is a brand new study that's just come out that did this study in the Amazon, studying the deltas of these rivers. And they give a background. Methane, it's extremely potent greenhouse gas, etc., etc. Fossil fuels, landfills, coal deposits. Another major source is soggy wetlands full of decaying organic matter and methane belching microbes. Don't you love that imagery? Now, a new study shows that as sea levels rise at an increasing rate and flood river deltas, wetlands are expanding, as is the amount of methane they contribute to the atmosphere. So, this is a whole new source of elevated methane levels in the atmosphere. So I'll leave the link below so that you can read this article. It's not very long. But they figured out that overall global methane emissions are increasing by about 25 teragrams a year, with total annual emissions at around 550 teragrams according to NASA. The study found that annual methane emissions due to sea level rise increased by 3.13 teragrams per year during the 22-year period, and 1 teragram equals about 1 million U.S. tons, or more than the weight of 200,000 elephants. So that's quite a bit of methane, I'd say. So according to the researchers, this new study shows that sea level rise is an important and previously overlooked methane source. So, there's that. I knew that would thrill you. Okay, our movie's going here in the Arctic, and we can see huge methane releases over here where the Atlantic is joining the Arctic Ocean. I think if we look at sea surface temperatures, anomalies, that it's quite high over there. Let's get to the right view. Yes, it's quite high. We're looking at this area here. See, it's in the red zone. It's way up there. Much higher all the way around the coast than it should be. And that's where, that's where our methane is really coming up. And there's no ice there anymore. Remember, the ice has retreated to around, it's inside that 80-degree north latitude. It's well within that 80-degree latitude on this east side. And you can see United States, it just is a big black blob. I mean, I saw this today and I knew I'd have to do a climate update soon because this is shocking. So let's run the movie on the world view. So the data is the 29th and 30th, which was Sunday and Monday, and then it runs into the forecast period. And look at Alaska. There's a lot of methane coming up in Alaska. So anywhere you have soggy land, you're going to have methane because you have decomposing material. I'm going to move this up so we can see New Zealand. So there you have it. So there's our climate cast update for today. Time is short. It's time to get your spiritual houses in order. We're going to be talking about spiritual stuff in our campfire chats. I'm going to try and focus it a little bit more on spiritual things, but I need callers to call in so we can talk. I only had one person call in, and that was Robin last time, and he joined on the computer from New Zealand. So if you want to call in and talk, let's talk. So my name's Margo. My website is margoshealingcorner.com. I'm a hypnotist, holistic life coach, empathic spiritual healer, and I'm focusing 100% of my time and efforts to helping prepare people for what is to come and showing them where we're at climate-wise, because we're obviously not being shown the truth and obviously not being shown how dire the situation is. I think it's much worse, and we're much further down the road than people are saying. So until next time, God bless everyone. Take care, and good night. I love you. Good night.